So today you're going to be working on 824 and 825. So I'm going to break this up into a couple separate sections. So I'm going to start with 824. We'll talk about 89, 90, and if we have some time, we'll try and get into 91 before I cut this video off. So last class we talked a little bit about how to make a table for a quadratic equation of some kind. But how are we supposed to work that backwards? So this time going from having a table like we have here to the equation that we want to make. So you've been given two tables here that you need to work with. It says examine this new connection that requires you to reverse your understanding of the zero product property as you find a rule for each table below. Using each table, find the x-intercepts and create the equation of the parabola in x minus a, x minus b form. So what they're trying to ask us to do right now is to look at our table and find the x-intercepts. If you remember, last class we talked about what you need to find for an x-intercept. We said that the y value was always going to be 0. So looking at my table, I see right here and right here, I have my x-intercepts because the y values are both 0. So what that means is that I can write my equation going y equals, and then it says x minus a, x minus b form, because what that means is this needs to work out so that -3 is the answer to make it 0. So what I need to do is something minus something needs, or -3 minus something needs to work out to 0. So -3 minus -3 will give me 0, which would mean that -3 minus a negative would be +3. So this works out so that -3 makes this 0. So that's my first factor. My second factor is probably a little bit easier because it's a positive number. So I'm saying 2 minus something needs to make 0. Well, 2 minus 2 would give me 0. So this, what I've just written here, is my equation that has those two factors. That's all I'm looking for you to do in part A and part B. So when you're looking ahead to part B, you're going to do the same thing. You're looking for your two x-intercepts. So I see them here and here, right? Oh, I'm off a box. 1, 0. And I'm going to use those to create my equation. So I'm going to say y equals 2 parentheses. And I'm saying -5 minus something needs to make 0, and -5 minus a -5, or -5 plus 5, would make 0. The other parenthesis, since it needs to be 1 minus something needs to make 0, that means 1 minus 1. This is my equation for part B. So when we're thinking about this, again, we're looking for our x-intercepts, and that helps us create these equations. The thing that's kind of convenient about it is that it almost always seems to turn out to be like kind of the opposite of what you see. So I see a -3 here, I see a +3 there. I see a +2 here, I see a -2 there. Now there will be exceptions to this rule as we move forward, but in general, that seems to be a pattern that we can kind of count on. Now looking ahead to 90, it's a problem about you working in quality assurance at the function factory. So your job is to make sure that clients are happy. Whenever a client writes to the company, you must reply with clear directions that will solve his or her problem. So you have graphing technology, Desmos, and a team of employees to help you figure this out. So there are 3 separate complaints that we are going to look at. You're going to need Desmos, so somebody at your table should pull up Desmos in order to study this situation. Work with your team and see if you can resolve the situation. So if we look ahead, the first situation says I followed all directions given in your brochure about how to order a parabola. I tried to order a parabola that passed through the points 1, 0 and -6, 0, only to have you send me the wrong one. So what we're going to want to do is pull up Desmos and see if we can create a parabola that will go through those 2 points. So they were 1, 0 and -6, 0. Hopefully you're noticing that this is very similar to what we just did in our creating the functions problem. I'm giving you the x-intercepts. So you're able to plug in our format where it's going to be x minus some number and x minus another number in order to go through those 2 points. I won't tell you what those 2 points should be here, but see if you can figure out what would need to go here and what would need to go here in order to make our parabola work. And you can test out some different things. So maybe I think my numbers are going to be 3 and 4. And I see, oop, that didn't quite go through the points I want. Maybe if I try positive 3. And you can keep playing around with it until you figure it out. However, the work we did in 90 should help you get started. The second one from Texas says that she wants the parabola to hit the x-axis only once at 5, 0. So she's looking for a situation where it just touches the parabola at 5, 0. So again, setting up the same format, I'm looking for this graph to only touch the x-axis there. My hint to you for this one was, don't be afraid to use the same number. That might help you create the parabola. Finally, for Alaska, she gives us a picture here of what she's looking for, and we just have to create the equation that models that. So what I would do is look at this parabola and see if I can come up with a few points to help me figure it out. So I see a point on the graph at 2, 0. I see a point on the graph at 0, 6, right here. And then to me, this x-intercept looks like it's at negative 3, 0. So as I'm trying to create my parabola, I can use those 3 points to help me figure it out. I also noticed that it's upside down. So keep in mind that in order to make things go negative, we're going to have to put a negative sign out front. So something kind of like this. And then I just got to figure out what numbers are going to have to go in here in order to make this all work. Okay. As you move on down into 91, they're referring back to our water balloon problem from a few class periods ago. So that you have a graph paper where we had those 4 different parabolas that we were looking at. So it says a journalist from the school newspaper wants to publish the results from a water balloon contest. She wants a rule for each toss so she can go and program her computer to create a graph for her article. You already have the rule for the toss made by Maggie from problem 855. So we already have Maggie's. That is negative x squared plus 17x minus 42. So the journalist knows that a factored form of an equation is y equals a, parenthesis, x plus b, x plus c. Now, I wrote up above using x minus a, x minus b. Minus and plus, you could set it up either way. It just matters that in the end, we correctly fill out those pieces to make that zero product property work. So what they're trying to get us to notice here is that this x plus b and x plus c sort of setup is representing our x-intercepts. So the b and c are the x-intercepts of the graph. So it says, examine the graph at right that represents the height of Jen's toss. The journalist found a rule for this parabola that was y equals a, parenthesis, x minus 0, parenthesis, x minus 8, but didn't know what the value of a was. Explain to the journalist how she could find the value of a. What they're looking for you to notice is we know some other points on the parabola. So what we could do is kind of like what we used to do for when we were solving linear equations. We can actually plug in a number just like when we found the slope and then you had to find the y-intercept. We could plug in a point for x and y and solve for a. So on Jen's parabola, we know that it goes through the point 4, 32 because that's the peak of her parabola. So 4, 32, I'm going to plug 4 in for x, and then I'm going to plug 32 in for y. And so what I end up with is 32 equals a 4 minus 0, 4 minus 8. Now I'm going to go through and simplify using PEMDAS. So order of operations, I need to simplify my parentheses first. So 32 equals a. 4 minus 0 is 4. 4 minus 8 is negative 4. Next would be any exponents, which we don't have, but then we need to move on into any multiplying or dividing that we have. So I can multiply these two pieces together to get 32 equals a times negative 16. And from here, I can solve for a by dividing by negative 16 on both sides and getting negative 2 equals a. So what that means is in my original equation up here, I can actually take out this a and replace it with a negative 2. And that would model Jen's parabola. So if I go back over to my Desmos graph and type in this equation that we think we have, y equals negative 2, x minus 0, x minus 8, I do get a parabola that goes through the point 432, so that peak point that I see on the graph, and it does land at 8, and it launches from 0. So this does model Jen's parabola. Moving on to C, it asks us to actually write the equation, which is what I just did. Part D wants us to create the equation that represents his toss. And then part E wants us to represent the equation for Imp's toss. So I want you to create those two equations on your own. Keep in mind that for Imp's water balloon toss, we only had the table, so it might not be a bad idea to plot some of those points. Notice our table doesn't include the other end of the parabola, but maybe your previous graph, the one that we did in class, would include the other end, our other x-intercept, to help you create that graph. When you're done, you can check your work against my answers.